the question is, what is a rigid body? So a rigid body is something that's going to be attached to the ball. So if, I'll hop back to the other one soon, but on the ball, it has two things to make it interact with physics. It has a collider. So in this case, it's sort of like its shape for physics things. And it has a rigid body, which means that forces can act on it. So when you have something like a rigid body, this means that now that we have a rigid body on this ball, it can be affected by gravity and stuff like that. I'll actually show you really quick what it can do. So if we hop back over, is everybody good with the code? Cool. So if we hop back over, let's go ahead and create a 3D object, and let's just do a cube. That's going to pop it out in the middle of nowhere for me. You can always right click, or not right click, you can always click up here and then say reset. It'll put it back at the center for you. And I'm going to sort of just drag it over here. And if we look at this object, we can see everything that's attached to it over here. So we have a cube, mesh render, and we also have a box collider. So similar to what we were talking about before, this, in this case, has a box collider. So now when I press play, you'll see that there's a box there, but it doesn't get affected. But when I jump, I get hit by it. So it does collide with things, but it's not necessarily being acted on by physics. But if we go and we click on the add component, and we type rigid body, boom, and then maybe I rotate this cube a little bit to make it more interesting. And if we press play, then it falls down. So now physics acts on it, and it's this physics object that exists in our world, more so than everything else, I suppose. So that's, I guess, the idea. Is that good for what a rigid body is? I'm going to assume that's yes. Cool. So we can use this cube right here as our power up, actually. So what we're going to do is I'm going to take it and just scale it down a little bit. That's using the scale tool, which is up here. Or you can press R, and taking it and just getting a good angle and dragging it down a little bit. Right about there. That looks pretty good to me. I can just move it down a tad. So in this case, remember I talked about that global versus local thing a little bit earlier? It was sort of a side note. So this is a great example to show what it does. So if I click on global, it'll switch over to local, and you'll see that the arrows on this cube actually change. So when I click on it, switches from that. So this is really great if I want to move the cube up in the direction that it is. But if I just want to move the cube down in the world, it's going to be really difficult because none of these line up. So that's when I would click on local, and now it just lets me drag it up and down perfectly. So that's a quick sort of primer of what local versus global can do. But question?
Where did you get the small cube?
I dragged it in a normal cube, and then I scaled it down using the scale tool. Cool. So I have our cube. Everything's more or less working, but remember we have to make it a trigger if we want it to be a power-up. So let's click on the is trigger button right there. And also I like renaming things. I haven't done it with all of these because it'd be a pain, but I'll rename this to SuperJump power-up. Cool. And the issue right now, if I press play, is that it's going to fall through the world and just go on forever. And the reason for this, anybody have an idea of why this would happen?
What would happen?
Why would it, when I press play like this, it will just fall through the ground and go on forever? But it still is a rigid body, so it's still going to be affected by gravity and stuff. So a way to avoid this is by clicking is kinematic, or by just taking the rigid body off altogether. There's a slight difference between doing is kinematic, so if I click is kinematic, and then press play, I'll explain what it does after this. You'll see it stays in the air. So this is something that people mess up a lot of the time in Unity. It's a pretty small thing, and it doesn't really affect you all that much most of the time. But whenever you have an object that has a collider and will be moving, so in the case of this, I actually want to make the power-up rotate around in the future, so I know I want it to be moving. In that case, you actually want to put a rigid body on it, and you want to check is kinematic, and it's like an optimization for the engine to make it so that they don't have to keep recalculating things as the collider goes around. This lets Unity know we plan to move this around. Don't worry about it. Don't freak out. Like, just sort of ignore it. If you don't do it, then Unity is going to have to like keep calculating things as you move it around and keep trying to like figure things out. So this is just us being nice to Unity in a sense.